Myself, G. Revati, working as Assistant Professor in the Department of Electronics and Instrumentation Engineering at Erode Sengundar Engineering College. Today we are going to learn about data network fundamentals, which is the basic chapter in industrial data networks. Basically, this chapter covers what are the different types of networks we are using and what are the different standards, topologies, then various protocols that has been used in the industry, that too in the automation industry. In this unit we will learn about the basic concepts that are used in networking area and different protocols that we are going to use in the industry, that has been used in the industry. First we will see what is a network. A network is generally defined as a set of devices connected by media links. A set of devices, otherwise also known as node. That means a node can be a computer, printer, or any other device which is capable of sending or receiving data generated by other nodes on the network. The links connecting the devices are often called as communication channels. Now, a computer network is generally defined as the interconnected collection of autonomous computers. When we are what is meant by distributed system? Distributed system is defined as a software system built on the top of a network. The perks of distributed processing are as follows. It provides a security or encapsulation. That too, security with redundancy is the add-on for this. Distributed database circuit switching, packet switching, message switching. Circuit switching is further classified as space division switching and time division switching. Packet switching is further classified as virtual circuit approach and datagram approach, in which virtual circuit approach is further subclassified as SVC and PVC. Now, we will see about the circuit switching. Circuit switching creates a direct physical connection between two devices such as phones or computer. For example, instead of point-to-point connection between the 3 computers on the left to the 4 computers on the right requires 12 links, we can use 4 switches to reduce the number and total length of the link. Computer A is connected through switch 1, 2 and 3 to the computer D. By moving the levers of the switch, any computer on the left can be connected to any computer on the right. The circuit switch is a device with N inputs and M outputs that create a temporary connection between an input link and an output link. The number of input does not have to match the number of output. An N by N folded switch can connect N lines in full duplex mode. For example, it can connect N telephones in such a way that each phone can be connected to every other phone. Circuit switching can use either two technologies. It can use space division switch or time division switch. The next is about packet switching. In packet switching, the data are transmitted in discrete units of potentially variable length blocks called packets. The maximum length of packet is established by the network. Longer transmissions are broken up into multiple packets. Each N packet contains not only data but also a header with control information. These packets are sent over the network from node to node. At each node, the packet is stored briefly, then routed according to the information in its header. The two popular approaches in packet switching are datagram approach and virtual circuit approach. In datagram approach, each packet is called as datagram, is treated as a separate entity. Each packet is routed independently through the network. Therefore, the packets contains a header with the full information about the destination. Whereas in virtual circuit approach, the relationship between all packets belong to a message or a session is preserved. A single route is chosen between the sender and the receiver at the beginning of the session. When the data are sent, all packets of the transmission travel one after another along that route. Virtual circuit transmission is implemented in two formats: switch virtual circuit, that is known as SVC, and permanent virtual circuit, that is known as PVC. Message switching. It's best known by the descriptive terms store and forward. In this mechanism, a node receives a message, stores it until the appropriate route is free, then sends it along. Store and forward is considered as a switching technique because there is no direct link between the sender and receiver of a transmission. A message is delivered to the node along one path, then rerouted along another to its destination. In message switching, the messages are stored and relayed from the secondary storage, while in packet switching, the packets are stored and forwarded from the primary storage. Message switching is common in the year 1960 and 1970. The primary uses have been provided high-level network service for unintelligent devices. The delay inherits in the process as well as requirements for the large capacity storage media at each node make it unpopular for direct communication. The next important topic is Open System Interconnection Model of ISO, International Standard Organization. It is established in the year 1947. The OSI model is based on a proposal developed by the International Standard Organization as a first step towards international standardization of protocols used in various layers. The model is called as OSI reference model because it deals with connecting open systems that are open for communication with other systems. It was first introduced in the late 1970s. The OSI model is not a protocol. It is a model for underlaying and designing a network architecture that is flexible, robust and interoperable. OSI reference model has 7 layers, that is physical, data link, network, transport, session, presentation, and the last layer is application layer. The principles that were applied to arrive the 7 layer are as follows. A layer should be created where a different level of abstraction is needed. Each layer should perform well-defined function. The function of each layer should be chosen with an eye toward defining internationally standardized protocols. The layer boundary should be chosen to minimize the information flow across the interfaces. The number of layers should be large enough that distinct functions need not be thrown together in the same layer. When a message is sent from device A to device B, as the message travels from A to B, it may pass through many intermediate nodes. These intermediate nodes usually involve only the first 3 layers of the OSI model. In developing the model, the designer distilled the process of transmitting data to its most fundamental elements. They identified which networking function had related uses and collected those functions into discrete groups that became the layer. Each layer defines a family of functions distinct from those of the other layer. Now we will see about the functions or attributes of each and every layer of the open system interconnection model. First layer is physical layer. This layer coordinates the functions required to transmit a bit stream over a physical medium. It deals with the mechanical and electrical specifications of interface and transmission medium. It also defines the procedures and functions that physical device and interfaces have to perform for transmission to occur. The physical layer is connected with the following specification. The first is about physical characteristics of interface and media. In this we have to define the type of transmission medium we are going to use. Then second one is representation of bit. It consists of a stream of bits without any interpretation. The bits must be encoded into signals, either optical or electrical. It defines the type of encoding. The third one is data rate. The transmission rate has to be identified in this physical layer. It defines the duration of a bit, which is long it lasts. Then next one is about synchronization of bit. The sender and receiver must be synchronized with the bit levels. That is, the sender and receiver clock must be synchronized. The next is about line configuration. We have to define what type of configuration we are going to use in this layer. It can be either point to point, broadcast or multi-point configuration. The next is topology. What kind of topology can be used is decided in this physical layer. The last one is transmission mode. In this we define the direction of transmission between two devices. It can be, the transmission may be simplex, half duplex or full duplex. The second layer is data link layer. This layer transforms a physical layer into data link layer. That is, raw transmission takes place in it. It is used to establish the link and enables the node-to-node delivery. It has specific responsibilities like framing, physical addressing, flow and error control and access control. The third layer is network layer. Network layer is responsible for the source to the destination delivery of a packet possibly across multiple networks, whereas the data link layer oversees the delivery of packet between two systems. The specific responsibilities of network layer are logical addressing and routing. The fourth layer is transport layer. This is responsible for source through destination delivery of entire message, whereas in network layer we have seen the delivery of packet, whereas in transport layer we can deliver the entire message. The specific responsibilities of transport layer are service point addressing, segmentation and reassembly, connection control, flow control and error control. The fifth layer is session layer. Session layer is also known as network dialog controller. It establishes, maintains and synchronizes the interaction between communicating systems. The specific responsibilities of session layer are dialog control, synchronization. Then the sixth layer is presentation layer. This is concerned with the syntax and semantics of the information exchanged between the two systems. The responsibilities of presentation layer are translation and encryption. The last layer is about application layer. This enables the user, whether human or software, to access the network. It provides user interface and support for the service such as electronic mail, remove file access and transfer, shared database management and other type of distributed information. The specific responsibilities of the application layer are network virtual terminal, file transfer, access and management, mail services and directory services. Next we will see about data link protocol. Generally, protocol in data communication is defined as a set of rules or specification used to implement one or more layers of the OSI model. In data link protocol, it is defined as a set of specification used to implement in data link layer. It is classified into synchronous protocol and asynchronous protocol. Asynchronous protocol will treat each character in a bit stream independently, whereas in synchronous protocol it takes the whole bit stream and divides it for further transmission. Synchronous protocol is classified into character oriented protocol and bit oriented protocol. Character oriented protocol will interpret a transmission frame or packet as succession of characters, each usually composed of 1 byte. All control information is in the form of existing character encoding system. Whereas in bit oriented protocol, it interrupts a transmission frame or packet as succession of individual bit. Control information in this can be one or more bits depending on the information embedded in this pattern. Bit oriented protocol is further classified into 4 different types. SDLC, that is synchronous data link control, HDLC, high level data link control, LAP, link access procedure, then last one is LAN, local area network. Now we will see about high level data link control. It was defined by ISO, that is International Standard Organization, for the use of both point to point and multi-point data links. It supports both half duplex and full duplex communication. It is a bit oriented data link protocol. Next, we have 3 different type of stations available in HDLC, that is primary, secondary and combined station. Then 3 different data transfer modes are used. They are normal response mode, asynchronous response mode, asynchronous balanced mode. 3 type of frames are used in HDLC: unnumbered frame, information frame and supervisory frame. Now we will see what are the work of 3 stations that we are using in HDLC. First one is primary station. It has the responsibility of controlling the operation of data flow. It handles the error recovery in an excellent way. Frames issued by the primary station are called as command. The secondary station will operate under the control of a primary station. The frame issued by secondary station are called as response. The primary station maintains a separate logical link with each secondary station. In combined station, they both act as a primary and secondary station. Then the three modes of data transfer operation are as follows. First one is normal response mode. Secondary station can only send information when the primary station instruct it to do so. Two common configurations, that is we can use either point-to-point link or multi-point link. In asynchronous response mode, more independent secondary stations are available. It can send or control information without explicit permission to do so. In asynchronous balanced mode, it is mainly used in point-to-point links for communication between combined stations. Either station can send data, control information and commands. The three different frames that's already stated as unnumbered, information frame and supervisory frame. They are used in, unnumbered frames are used in link setup and disconnection. They do not contain the acknowledgement bit in the unnumbered frame. In information frame, which carry the actual information, it can be a piggy bank acknowledgement in case of asynchronous balance mode. In supervisory frame, it is used for error and flow control purpose and hence contain send and receive sequence numbers. This is the general HDLC frame structure. It consists of flag, address, control, information, FCS and flag. Header and footer flag is used to denote the incoming and outgoing of the data. In address field, the address of the data will be denoted. These are the three different frames that HDLC uses. FCS is known as frame check sequence. It is used for error detection. It can contain either 2 or 4 byte cyclic redundancy checking. Okay, the next protocol is media access control. It's otherwise known as MAC. MAC layer protocol is the protocol that controls access to the physical transmission medium on a LAN. It tries to ensure that no two nodes are interfering with each other's transmission and deals with the situation when they interfere with each other. It also contains a synchronization, flag, flow and error control specification which is required to move information from one place to another place. This is the layer of media access control. It consists of physical layer, MAC layer and logical link control layer. Okay, now we will see the working of media access protocol with the help of this flow chart. Every time a sender wants to transmit a bit sequence having more than 5 consecutive ones, it will insert one redundant 0 after the 5th one. For example, the consequence is 0, 1 1 1 1 1 1 1 1 0 0 0. It becomes 0 1 1 1 1 1 0 1 1 1 0 0 0. This extra 0 is inserted regardless of whether the 6th bit is 1 or not. Its presence tells that the receiver has seen the stuffed 0. It is dropped from data and the original bit stream is restored. Bit stuffing is required whenever 5 ones occur consecutively with three exceptions. They are when bit sequence is really Q flag, when transmission is being aborted, when channel is being put to ideal. As the receiver reads the incoming bit, it counts the ones. When it finds 5 consecutive ones after a 0, it checks the next. If it is a 0, the receiver recognizes it as a stuffed bit, discards it and resets the counter. If the 7th bit is a 1, the receiver checks the 8th bit. If it is 0, the sequence is recognized as a flap and treated accordingly. A total of 7 to 14 consecutive ones indicate an lost. A total of 15 or more is indicated as an ideal channel. The next topic is CSMA CD, which is known as carrier sense multiplexes with collision detection. Whenever multiple users have unregulated access to a single line, there is a danger of signals overlapping and destroying each other. Such overlaps turn the signals into unusable noises called collision. As the traffic increases on a multiple access link, so do the collision. That is, whenever the traffic increases, the chance of a collision occurring will also get increased. A LAN therefore needs a mechanism to coordinate traffic, minimize the number of collisions that occur and maximize the number of frames delivered successfully. The access mechanism used in an Ethernet is called carrier sense multiple access with collision detection. The original design was a multiple access method. Every workstation has equal access to everyone. There was no provision for traffic coordination. Access to the line was open to any mode at any time. In a CSMA system, any workstation wishing to transmit must first listen for existing traffic on the line. A device listens by checking for a voltage is detected. The line is considered ideal and the transmission is initiated. CSMA cuts down on the number of collisions but does not eliminate them. Collisions can still occur. The final step is the addition of collision detection. In CSMA CD, the station wishing to transmit first listens to make certain that the link is free and then transmits its data. Then listens again. During the data transmission, the station checks the line. Each station on the Ethernet network has its own network interface card that is known as NIC. The station provides 6-byte physical address which is unique. We can see the frame format for CSMA CD. It consists of preamble. Preamble consists of 7 bytes with alternating zeros and ones that alerts the receiving system to the coming frame and enable it to the synchronization for input timing. The pattern 1010101 provides only an alert and timing pulse. The second frame is start frame delimiter, which is known as SFD. This signals the beginning of the frame. This tells the receiver that everything that follows is data starting with the address. The next one is destination address, which is known as DA. This is allotted 6 bytes and contains the physical address of the packet's next destination. When packet reaches the target network, the destination address field contains the physical address of the destination device. The next one is source address. It is also alerted with 6 bytes and contains the physical address of the last device to forward the packet. The next frame is length or the type of PDU. PDU is otherwise known as Protocol Data Unit. If length of PDU is fixed, it can be used to indicate the type or as the base for other protocols. The next one is data and padding. Data and padding is used to control the information and the type of database that has to be transmitted to the destination address. The last frame is CRC, cyclic redundancy check. It is mainly used for error detection. Okay. The next one is token ring and token passing. Token ring frame format. The token ring frame format consists of SD stands for start delimiter. It has three different types of frames: data on command, token, abort. The first one is start delimiter. It is a 1 byte long and is used to alert the receiving station to the arrival of the frame as well as to allow its synchronization, its retrieval timing. It is equal to a flag field in HDLC. The next is about AC, which is known as access control. It is also 1 byte long and includes 4 subfields. The first 3 bits are priority field. The fourth bit is token bit. It is used to indicate that the frame is a data or command frame rather than a token or abort frame. The token bit is followed by a monitor bit. Finally, the last 3 bits are acts as a reservation field, which can be seen by the station wishing to reserve access to the ring. The next frame is FC, that is known as frame control. It is a 1 byte long and contains 2 fields. The first is a 1 bit field that indicates the type of information. The second is token ring PDU unit. The next one is destination address and source address, which contains the address of the destination and source. The next one is data. It is allotted 4500 bytes and contains PDU. A token ring frame does not include PDU length or the type of the field that is being used. The next is CRC. CRC stands for cyclic redundancy check. It contains 4 bytes and contains CRC32 error detection sequence. Then next is end delimiter. It indicates the end of sender's data and control sequence. Last frame is frame status. It can be set by the receiver to indicate that the frame has been read or by the monitor to indicate that the frame has already been around the ring. This is not an acknowledgement, but it tells the sender that the receiving station has copied the frame, which can now be discarded. Now we will see how the token is passed in the token ring. Whenever the network is unoccupied, it circulates a simple 3 byte token. This token is passed from NIC to NIC in sequence until it encounters a station with data to send. That station waits for the token to enter its network board. If the token is free, the station may then send a data frame. It keeps the token and sets a bit inside its NIC as a reminder that it has done so, and then sends it on data frame. This data frame proceeds around the ring, being regenerated by each station. Each intermediate station examines the destination address, finds that the frame is addressed to another station and relayed to its neighbor. The intended recipient recognizes its own address, copies the message, checks for error, and changes the 4 bits into the last byte of frame to indicate address recognized and frame occupied. The full packet then continues around the ring until it returns to the station that sent it. The sender receives the frame and recognizes itself in the source address field. It then examines the address recognized bit. If they are set, it knows the frame was received. The sender then discards the used data frame and releases the token back to the ring. This is how we can use token passing method to send a message immediately. The token ring and token passing also enables the command response protocol. The primary station sends the command. The secondary station will send the response. A combined station sends both the command and response. The configuration refers to the relationship of hardware devices on a link. We have three different type of stations, that is primary, secondary and combined station. It can be configured in three different ways, that are unbalanced, symmetrical and balanced. It can support both half duplex and full duplex transmission. In unbalanced configuration, one device is primary and the others are secondary. It can be point to point configuration only if two devices are involved. If more number of devices are involved, we can use multi-point configuration with one primary controlling several secondary devices. In symmetrical configuration, each physical station on a link consists of two logical stations. One is a primary and the other is a secondary. Separate lines link the primary aspect of one physical aspect of the station to the secondary aspect of the next station. A symmetrical configuration behaves like unbalanced configuration, except the control of link can shift between two stations. The last one is balanced configuration, in which the both stations are used. We can use point to point topology in the balanced configuration. The stations are linked by a single line that can be controlled by either station. When there is no data transmission, the token will circulate around the ring. If the station needs to send the data, it waits for the token. The station captures the token and sends one or more frames, and finally it releases the token to be used by the successor station. The advantage in using token ring or it is flexible control. It provides flexible control over access that it provides. The access of data transmission is fair. It is easy to provide priority and guaranteed bandwidth services. It also has certain disadvantages, like it requires extra work. Then the loss of token prevents further utilization of the ring. Duplication token can disrupt the operation. The monitor station is required. It becomes a crucial point for a single point failure. This is all about token passing and token ring.